All right. Well, welcome everybody. Good afternoon. My name is Jackie Stahl. I'm the chair of YPN South Bend and VP of Marketing of the South Bend Clinic. And welcome to the fourth and annual summit this year. Like last year, we are calling it the YP Summit Week due to our hybrid format of virtual and in-person programming throughout the week. We have virtual sessions again tomorrow and Thursday, and we'll wrap it all up with an in-person after party on Thursday at Generations Adventureplex. With the support of the South Bend Regional Chamber and program sponsors like Gibson and Indiana Michigan Power, YPN celebrates 16 years. We thank them for their support, along with this year's summit's presenting sponsor, the University of Notre Dame. And right now, we're going to hear a short video from Notre Dame. Amanda, if you want to play that.
On behalf of the University of Notre Dame, welcome to the YP Summit Week. The university is proud to be the presenting sponsor for this annual event because we believe young professionals are vital to successful organizations. We also believe it's important for young professionals to have a space to connect with each other and ourselves, especially during this challenging time. The past 19 months have been rough. Now more than ever, young professionals are at risk for burning out. Some of us have made adjustments to work from home, transitioned back to the office, or have been essential workers for our organizations all along. If you feel like you've put yourself on the back burner, this week is for you. I hope you take advantage of the awesome sessions and enjoy the after party. I encourage you to thank our YPN ambassadors for their hard work in making this event a success. Let's keep doing the right things with the goal of gathering in person next year.
All right. Thank you, Notre Dame. We appreciate that, and I think we can all relate to that message as well. Before I introduce our speaker today, stay tuned at the end of today's program for a chance to win a $25 gift card to Brewburger, courtesy of First Response. But you must be present to win, so don't jump off too quickly, and we'll have 2 to give away. And then now on with today's program. Our speaker is Dr. Nancy Michael. Dr. Michael is the Director of Undergraduate Studies for the Neuroscience and Behavior major at the University of Notre Dame. The 2018 Michiana 40 Under 40 recipients' dedication to excellence, innovation, and education and commitment to community wellness have earned her numerous teaching, advising, and community awards. Today, she'll speak about balance in your brain. Please welcome Dr. Nancy Michael.
Thank you so much, Jackie, and thanks for the opportunity to be here today. Hi, benchmark. I don't know, man, an hour and I can't see your faces and you have to stay on to the end of the call. So I'll do my best that I can to keep you engaged for the day. We are monitoring the chat and the Q&A. So if you do have questions, as things come up, please put them into the chat, and Jackie is gonna just kind of interrupt and so that we can do this as much conversationally as we can throughout the session today. So here we go. Balance in your brain. So I'm gonna hide my meeting controls. Doop. Boop. Okay, here we go. Balance in your brain. And so a big question is, right? I'm a neuroscientist by training, and behavioral neuroendocrinologist, if we're going to get technical. And so the brain, I think, has so much more to offer understanding of ourselves and understanding of others than we often give it credit for. And so one of the ways that I always start, because I think it really helps with understanding ourselves, is kind of going into brain development, which feels a little bit like a detour. But I think so often in today's kind of world, we have all of these like little life hack kinds of things. Protect your mornings, go outside, be active, right? Simplify, laugh. But really the question is, I think, is why are these even important? So what about the brain? What about neuroscience actually helps in understanding kind of the background rationale in terms of why these are suggestions in the first place? But I think more importantly has to do with what can we do within our own lives? Because when we look at all these things individually, it's like, oh my gosh, I don't have time for all of this stuff, right? Like this won't work for me, or this won't work for me, or maybe this one would. But if we can understand the rationale, if we can understand actually what our brain needs, then we can pick and choose and build on the strengths and the opportunities that we already have within our lives. So as an educator, first and foremost, here are the learning goals for today. Talking about the brain, so we need to define some brain basics. We're going to put this in a developmental context because every single brain, just like every single person, every single brain is unique in its architecture. And so we have to really take into account our own experiences and kind of the brain's expectations to be able to live our most healthy lives for ourselves. Right? Balance in the brain, man. We are all under the video. Is absolutely right. This last year and a half has been one heck of a time. And we all have live normal demands of daily life that we're always trying to manage on top of, however, the events of the last year and a half have really thrown things out of whack, with the ultimate goal of asking how we can take care of how can we best take care of ourselves and our own brain. So, ready? It'll be so exciting. Okay, crash course in neuroscience. I'm going to sum up all of my doctoral research, not all of it, maybe the first 3 years of my doctoral research in like a slide or two. Okay, it'll be so fun. So first and foremost, brains have these things called structure-function relationships. And really all that means is that certain parts of the brain, certain structures, like the frontal lobe, right, are associated with certain functions. And so the frontal lobe, this is what we like to think of as like our big, like fancy humanness. It's all of our problem solving and executive function kinds of things, the reasoning, long-term goal setting kinds of whatever. The frontal lobe has a particular function. The parietal lobe has a particular function, right? The occipital lobe is a different structure that has a different kind of function. So this is true at the macroscopic level, right? Like when you look at the brain and the neuroanatomy of the brain with your naked eye. But this is also true at the cellular level, right? So two major cell types inside of the brain. One is called our neurons, and the other is a group of cells or a classification of cells called glial cells. We're not going to talk too much about them today, but they are very, very important in an overall brain function. But in terms of structure-function relationships, then, from a cell perspective, here we have a neuron. This is a cartoon of a neuron. Here's the cell body. These branch-like things are called dendrites. And if you can think about a tree, right? We've all seen, we live in Indiana, lots of deciduous trees that lose their leaves, right? The branches on the trees are much like the dendrites of the cell, and the leaves on the trees are much like some small structures on the dendrites that bring in, there's sunlight, right, from the environment. Well, these structures in the neuron kind of bring in and generally receive information from other structures in the brain, from other neurons and glial cells. They send information down an axon, which can be thought of like the trunk of the tree, right? And then the axons, although there's only one axon, those axons can branch off and spread in so many different directions. But because those branch points are usually at a distance from the cell, we don't really think about them too much. So those are like the roots of the tree that go in all of these expansive directions under the ground that we don't see. But the reach and potential for communication is really, really extraordinary. And so in terms of structure-function relationships, each part of this neuron serves a very specific function for the cell. And so the way that this all plays in then in terms of brain function is that we have lots and lots of neurons that are receiving information all the time. So back to this roots of the tree analogy. We have axons coming in, right? And that's what these green and red things are. These are points of contact or points of communication that are coming in from another neuron's axon, sending information to be received by this dendritic tree, right? All the branches and everything that are on the big old oak tree at the park are receiving information from the environment. Same thing from these axons. And some of this information is what's considered excitatory in nature, right? Kind of gets you excited. You can think about actually how your body changes when you're excited. And so that's represented by the green input here on the neuron and by the green bumps down here in this diagram. We also have inhibitory information, which is represented by red, right? And with the red, it kind of puts the brakes on the system, inhibits, lowers the excitation. And so the way that neurons communicate with one another is through what's called electrochemical communication. So these little bumps are literally excitatory information coming in that raises the electrical potential of a cell. The red dips are inhibitory information that literally lowers the electrical potential of a cell. And so one way to think about this is like a rumor. Ready? It's a good one. Okay. So you have a friend, Johnny, and Johnny is going to ask Susie to the prom. Maybe many of us will have to rewind a number of years to think about what prom was like a couple of decades ago. But maybe for some of us, not so long ago. So Johnny, and you hear this rumor for the first time, right? And so you get a little bit excited. You're like, really? Is that actually going to happen? And then you hear it again. Then you hear it again from somebody else. And you're like, wait a second, what? No, right? But you're excited, right? You're at an elevated state compared to where you were before you heard the rumor. But then somebody else comes along, a pretty reasonable source, and they're like, no, that's not a thing because I heard that Susie was going with Adam, whatever. And you're like, oh, okay, that's fine. And so you're a little bit more inhibited, but you can't unhear the rumor, right? You don't drop down to baseline. That information still exists on some level. And then you hear some people say yes, and other people say no. But then you hear from maybe Johnny's mom herself that it's a thing. And you're like, oh, it must be true. And at that moment in time, you decide you're going to send that information on to all of your kind of contact and network partners. It's similar to the way that neurons work. They're receiving information all of the time, and they have to reach a certain threshold of excitation before they decide whether or not they're going to pass what's called an action potential on to their buddies, this electrical impulse, right? And then this impulse here is conducted along the axon and then releases a chemical messenger at those ends of the axon, right? So again, way extended down, right? That electrical impulse is sent down the trunk of the tree, sent down all of the roots at distant places through that root system underground, so that at the very tips of that root system, you're going to be sending out information into other parts of the brain environment. And so some of these chemicals are pretty common. We'll talk some more about them, but two that I want you to keep in mind are dopamine, which we hear a little bit about in pop culture, and then oxytocin, which we hear a lot about as like the cuddle hormone or the love hormone. Those two will be coming up later. In the context of brain development, life balance, and stress dose, our lifetime history matters a lot in the way that we perceive and engage with the world. And so this is just a quick graph. So we have the weight of the brain here over the age of life, our life course here. And what you might notice is that the weight of the brain increases dramatically in the first 5 years of life. Right? So if you go from a teeny tiny little sapling, right? Little teeny tiny little sapling seedling of a tree, and then over the first many, many years of life, that teeny tiny little seedling starts to grow more branches, starts to get bigger branches, starts to get lots and lots and lots of branches that are really, really robust and thick, and lots of leaves and this really rich foliage, right? This is literally the growth of neurons taking place that contributes to this growth in brain weight. And in a lot of this early growth, it's our experiences with the environment that really drive a lot of the direction in terms of the specific contacts that these neurons are making with each other, really in terms of laying the foundational framework of how different structures of the brain communicate with different other structures of the brain. How one structure function of the brain informs and sends information to another part of the brain to inform its function and our perception and thinking about the world around us and how we engage. All right. We always show pictures of one cell, and this is pretty atypical. There are lots of cells, but the brain actually has 86 billion neurons. What? And 86 billion glial cells. What? For a total of 1 times 10 to the 14th synapses, or those points of connections or communications. And these are giant numbers, well beyond anything that I deal with ever in my regular world. So this is just what they look like. So if you think about the likelihood that any one person's brain is exactly like somebody else's brain, we have a 1 in, 100 trillion chance of having the exact same brain as someone else, right? So the chances, right, we might have a lot of other very similar characteristics, but the chances of us having exactly the same experiences that lead to exactly the same perceptions of the world and thinking about the world, that the chances of that are virtually zero, right? So this all to say that from a developmental perspective, the brain is what's considered a situated organ, right? That it has to do with these early exchanges over the course of life that develop the very specific network and structures that allow for communication across the different parts of the brain, that allow for their functional qualities to emerge. So we say that behavior, then, all behavior is driven by the function of brain networks. And so the brain is a situated organ, and that it's an organ that's born really, really immature, develops over the first many, many years of life. It's situated in its environment, and our behavior emerges as a property of brain function in coordination with what we've learned from our environment. So it's not that 86 billion neurons and 86 billion glial cells are just kind of randomly placed in a bucket, but it's because they're organized in a very particular way that allows the particular functions to emerge as a quality of the organization. And that organization occurs not only on the macroscopic, right, frontal lobe, parietal lobe, the macroscopic scale, but on the microscopic scale of very, very specific neuronal structure and function. Okay. So at this point, maybe we can take a moment to just visit the chat, Jackie. I don't know if there's any questions at this point, insights, thoughts, reactions, just a quick check for understanding. Okay, I'm going to say that that's probably a no then, and I will move on in. All right, so putting this then in the context of development, we have these critical periods or sensitive periods of development, right? We spend a lot of time talking about neurons, about structure, function, relationships. And again, if you remember that massive brain growth that occurs during the first number of years of life, we can say that there are certain periods of brain development that are a little bit more important for an individual's brain growth. All right. Okay. So critical periods or sensitive periods are basically sensitive periods during development where a domain-specific stimuli, which means like vision. If anybody's ever had a kid with cataracts identified early, those cataracts have to be surgically removed very, very young, right? They try to do that surgery within the first year of life, because otherwise, without the visual input from the eye, the brain is actually going to start to reorganize and reallocate its resources to a different sensory domain. Okay, so really sensitive periods are restricted periods of development that determines the systems, right? The brain's structure and function, the level of reactivity to the external world for the rest of the animal's life. And luckily for us, there is some plasticity, but if you remember again, that growth curve, the first 5 years of life are really, really critical in allowing the opportunities for the brain to develop many, many, many possibilities, as many possibilities as the environment will allow, so that as we age, we can trim some stuff back, right? Again, trees will grow unchecked until a storm comes through and chops off all those weak branches or blows down all those weak branches. The brain goes through a similar process of refinement as we age, because some connections we just don't use very much. And so in terms of efficiency, we trim down, right? We have the storm of adolescence, right? The storm comes through during the decade of adolescence that kind of blows off the weak branches that we don't really use anymore. So adolescence is another very sensitive period of brain development and brain reorganization. And it's because of that reorganization that we have a lot of these kind of adolescent typical behaviors. Okay. So is it possible in the chat at this point in time to do a little bit of brainstorming? And then Jackie and Amanda, if you can maybe relay some of that chat information to me, that would be great. But I want you to think about kids, maybe yourself as a kid, maybe a kid that you know, maybe an infant that you know. And I want you to think about what's necessary for humans to make it out of childhood, right? What does a developing human need or expect from the environment around us? And again, however they... Food, absolutely. Yep. Don't survive long without food. Do it.
Food, water, protection, safety, nourishment, education.
Yep. Yeah, all of those things. And the younger that we are, all of those kind of what we would consider normative experiences or expectations are reliant upon an attachment figure, right? So this attachment figure becomes really, really critical in developing or allowing the opportunity for tiny brains to go through this massive branching to give them the most opportunity for the trimming back that comes during adolescence. And it's through these exchanges. So maybe some people have, watched some YouTube videos or done some reading on their own about this serve and return experience. It's these exchanges when we're young and when we're old as well, but especially critical when we're young, when we offer something out to the environment. How does the environment in turn respond to us? Are we met with love? Are we met with compassion, tenderness, fear, anger, neglect, cold, food, water, right? The attachment figure really is the conduit to all of these other survival needs, right? And it's through these exchanges, those exchanges are providing the environmental pressure. When we saw that, remember there was that panel, it was yellow with the black dots, right? Those black dots are the neurons and how they grow. And there were 3 panels. These early exchanges with their environment are providing the environmental pressure that kind of provides the directional force or the environmental force to say, what exactly is this neuronal structure going to be, right? All right. And so again, we come back to this idea that the brain is actually a situated organ, that this serve and return relationship between baby and caretaker is one of the most foundational and important relationships that establishes the foundational neural architecture and therefore the behavioral repertoire of all humans, right? Tremendous amount of pressure, but tremendous amount of opportunity. And I want us to start thinking about culture at this point in time. Because what we know in neuroscience is that attachment is foundationally important to healthy brain development. But culturally, we have all kinds of jokes and belittlements about mommy issues and daddy issues and a mama's boy, right? Like when we demonstrate attachment and affection for others, there's a lot of our culture that is insulting and belittling about that, which puts the cultural narrative at direct odds with what we actually need for brain health. Okay. So, talked about these chemical transmitters, right? So, electrochemical communication in this relationship, right? Our relationship with our caretaker is one of the most foundationally important for our brain health, for better or worse, right? Some of us, I think, are always thinking like, uh-oh, And others are thinking like, whoo, dodge that bullet, right? So again, every single brain is unique. Every single individual's experience is unique. One of the things that brought me back to graduate school, actually, so I worked for a number of years, went to college, worked for a number of years in the workforce, returned to graduate school when I was almost 30, with some of these questions about like my genetic family. I'm the middle of three, no judgment, the middle of three. And my siblings and I are so different, right? Same genetics, same household, same parent, same major life events. How on earth did we end up so different, right? And again, my sister had an opportunity of being an only child for almost 3 years. And then I was born and she was displaced, right? Was a younger sibling, one of two, for almost 4 years. And then my younger brother was born. With the addition of each kid, parents have a little bit less bandwidth, right? Attentional resources are a little bit more diminished because they're still only 24 hours in a day. So it's these kinds of things. The brain is a situated organ. It's born tremendously immature. And it's the experiences that we have along the way that provide the environmental pressure. Foundational to our experience are relationships. We do not survive out of infancy and childhood without a caregiver or multiple caregivers. And so the brain is expectant, right? The developing and developed brain actually has expectations of the environment. Foundational to this is relationship. And there are two neurotransmitters, or these chemical communicators in the brain. The first one is oxytocin. Again, this one gets a lot of popular press as the love hormone or the cuddle hormone. Peripherally, it's really important in actual childbirth. But oxytocin is a chemical in the brain that's released within the brain across so many different parts of the brain that are really, really critical for motivation, reinforcement, memory, emotional processing, stress management. Okay, so oxytocin very broadly has a function. When oxytocin is released, the function of oxytocin has to do very broadly with attachment, bonding, affiliation, community, trust, and altruism. Okay, and again, the social input, our community setting, as we're infants, children, adolescents, grown-ups, the social input is really the necessary, right? And social input is multisensory. Social input is the necessary sensory input that drives the release of oxytocin. So why is it so much more fulfilling, generally speaking, to do the exact same activity in person compared to Zoom? Zoom, right? All that sensory input is totally shifted in a Zoom platform. We have to be really, really, really intentional about developing relationships in a virtual world that we don't have to be so intentional about in an in-person world, because our brains evolved in person, right? And all of that multimodal sensory input necessarily drives oxytocin release that makes in-person settings far more rewarding. Second to this is dopamine. Now, dopamine in pop culture, we talk about as like the reward pathway. Dopamine neurobiologically is really considered reinforcement, right? So when we say the word reward, so this might get a little bit cloudy. So I apologize if anybody has any questions and be like, back up, that don't make any sense. Pop it into the chat. Jackie, please interrupt.
I actually did get a question.
Great, what's up?
So does the amount of oxytocin able to be released decrease with age and time?
Not as far as I know, right? So there is, I mean, neural degeneration happens in general as we age, but the more active we are, the more we keep in contact in social relationships, we can really, really, really kind of delay or mitigate and push back that process. But no, there is not a degenerative phenotype of oxytocin neurons that I am aware of, right? Not like, so dopamine degeneration can cause something like Parkinson's disease, but there is not a similar phenotype that exists or diagnostic criteria that would exist for oxytocin neurons. Does that answer your question?
I think it does. Yes, thank you.
Okay, great. Yeah, and please, any questions at any point in time? That makes it a little bit more fun for everybody, I think. All right, so dope, we got oxytocin. Oxytocin, you need that social interaction to drive the release of oxytocin. Dopamine, again, from a developmental perspective, is also is considered behavioral reinforcement. And I really want to stress this because when culturally we use the word like reward, it makes us think of generally pleasure, right? Like, ooh, this cookie tastes so good. And the cookie might taste delicious, and there might be some dopamine that's released in association with it. But the dopamine release just says, ooh, this behavioral pattern led to this outcome, and this was a positive outcome. I'm going to do this again. It really has nothing to do with the pleasure associated of eating a freshly baked cookie, right? So dopamine reinforcement would have to do with long-term goal, got a big project at work, there's a 3-month deadline, we've got this great strategic plan, and we work and we work and we work, and we have these incremental reinforcements when we accomplish these little tasks, but then we're able to submit the final proposal or the final project. There's a giant dump of dopamine that says, whew, we did it. And so it's that reinforcement that is responsible, right? So to say like all this hard work was worth it. We did a great job. We made our deadline and our board loves it, right? Behavioral reinforcement, really, really different than pleasure or reward. So anyway, all right. So dopamine release comes from a part in terms of behavioral reinforcement, comes from a part of the brain called the VTA or the ventral tegmental area. And again, in terms of how we perceive and engage with the world, dopamine can be released in a work setting. Aside from social settings, dopamine can be released if we're feeling thirsty and we get water, if we're going to lunch and all of a sudden there's a free lunch, right? Those kinds of things don't require oxytocin. But oxytocin can actually drive the release of dopamine, resulting functionally in social experiencing being one of the most neurobiologically reinforcing experiences that we can have, no matter our age. But our early environment, both oxytocin and dopamine, has a tremendous amount to do with how the structure and therefore the function of individual neurons and brains develop over time. Okay, we're finally here. So what about stress? We've spent so much time talking about development. What does this all have to do with stress? All right, so how about another chat opportunity? How many people, I wish we could just do a quick show of hands. How many people have felt stressed in the last year and a half at one point or another?
Well, we've got a lot of people raising their hands.
Yeah, I imagine so, right? And a different kind of stress, a different level of stress, right? Like, right, when you're doing your grown-up thing and adulting every day, there are normal stressors, but the last year and a half has offered really exceptional opportunity to experience historically abnormal stressors, I would say, right? And so this comes from a different network within the brain. Again, structure, function, relationships. We have dopamine cell bodies that release dopamine across their root systems all over, oxytocin cell bodies, right? Stress perception has to do with what we've learned over the course of our history. So there are a couple of natural, right? So loud noises and rapid movement are two things that we're naturally afraid of. And when I say afraid, I don't mean like horror movie afraid. What I mean from a neurobiological perspective is that those are two things that we will naturally startle and attend to. And the initial response, if we don't know what it is a freezing behavior because we're like, oh gosh, what is that? Beyond that, anything here, right? We've got, oh my gosh, there's a scorpion. Okay, we live in northern Indiana. Not too many scorpions around unless you go to the zoo, right? Okay, so, oh my gosh, there's a scorpion. When we're young, right? Infant, toddler, child, we don't know structure, function, relationship. We don't know to be afraid of a scorpion. We acquire that hesitation to engage with a scorpion over time. So let's imagine a world in which there's a little toddler walking around, scorpions are running everywhere. I don't know. Just play with me here for a little bit, right? Little toddler walking around, scorpions are, let's imagine that they're in St. Pat's Park, right? Okay, fine. But a little toddler is going to look at that really crazy body shape and probably be pretty curious, right? So a little toddler's going to waddle on up and want to pick up the scorpion. In an attending world, right, there's going to be a caregiver nearby that's going to rush in, grab toddler out of the way right before toddler gets stung or something. And then toddler's going to do what? Toddler's probably going to be startled. Toddler's probably going to start crying, because in toddler's world, toddler was just exploring, because that's what they do, right? Little brains, tiny brains want to know everything they possibly can about the environment. And somebody mentioned education in the chat earlier. From a long game human perspective, education wasn't necessarily school. Education was this serve and return mentorship and reciprocal relationship that developed with us in an age appropriate fashion. So early on, oh my gosh, there's a scorpion. This little toddler, right, is scared now, because toddler thinks that they've done something wrong, right? But then, right, so oxytocin, dopamine have probably decreased pretty dramatically, right? So that's called an error signal. So we have a major dip in those two neurotransmitter systems in this sensory experience, visual sensory experience, the smell of being outdoors, the sounds of being outdoors in a particular location at St. Pat's Park. Caregiver, the goal of caregiver was to attend and care for a child, right? But has now scared child. So now part of that educational process and developing a structure function relationship that allows for calming is now dependent on caregiver to be like, oh, kiddo, it's okay. No, the scorpion's just dangerous, right? You can't do that. I want you to stay safe, right? Let's find something else. Let's explore something safe, right? So it's now on the responsibility of caregiver to to set the example of what it looks like for a physiology to calm down. Because in that moment, when caregiver rushed in, baby, infant, toddler, child stress response gets jacked up. And then over time, that's how we learn, right? Structure, environmental pressure develops the structure that underlies the function. Over time, the pairing of this stimulus with the behavioral response is how we learn that certain things are dangerous, certain things are stressful, certain things are to be avoided. But most of those things are learned over time based on lots of really complicated environmental, cultural, and familial processes. Okay, so we can generalize this as a stressor. And again, whatever the ubiquitous stressor is, and whatever the management, however that management occurs through our family and our caregivers over time, develops the direction of the brain the microarchitecture within the brain. Okay, so the stress response in general, we have a sensory experience that comes in. We have a chain reaction of events. So if anybody's ever seen one of those like cascading fountains, right, where it's really tiny at the top and the water trickles down and it impacts a broader area, and the water trickles down and it impacts the broadest base. That's how you can think about the stress, the cascade of the stress response. We have sensory input that comes in through some kind of sensory modality, right? It could be a sound, it can be a sight, it can be a smell, it can be a taste, and it can trigger a really, based on previous learning and based on the architecture that's been established in our brain, it can trigger this really robust stress response. It's triggered at the level of the amygdala, actually, but we always talk about it as the HPA, or the hypothalamic pituitary adrenal axis. Stressor comes in, activates this cascading response, and then we have this thing called cortisol. We've all heard about cortisol. Gets a really bad rap in the literature as the stress hormone. Well, we need cortisol. We need it. We need it to wake up in the morning. We need it to feel motivated. The problem, the health consequences come when there's too much cortisol around for too long. In a normative environment, right, acute stressors, right, from an evolutionary human long game perspective, stressors have been considered acute, right? They're momentary, they're not long lasting, right? So the way that the stress response actually evolved was that once cortisol gets into the bloodstream, it becomes what's called an endocrine factor. So it gets carried around in the bloodstream and slowly makes its way back to the brain. Okay. Once cortisol reaches a part of the brain called the hippocampus is like, oh, okay, time to shut that stress response down. So under normal circumstances or normative circumstances, cortisol takes a little bit of time, gets back to the hippocampus. Hippocampus senses the cortisol in the environment, and the hippocampus shuts down the stress response. That isn't, if the condition that needs to be met in this situation, though, is that the stressor is removed. Okay. How many of us live in a situation from a cultural perspective or from a work perspective in which the stressor is ever removed, right? An acute stressor, oh my gosh, I almost just got in an accident. Whew, dodge that bullet, stressor's gone. Prolonged chronic stressor, email is one for me, right? How many people have spent so much time trying to catch up on email that like just the thought of it sometimes is like nauseating? That's a very innocuous example. Prolonged chronic stressor, economic instability, community violence, bullying in schools, uncertainty of a pandemic, uncertainty of job stability, right? A lot of these things, right? We live with a lot of prolonged chronic stressors in ways that are at a great distance from how our neurobiology and physiology evolved, right? So they put tremendous pressure on the system. And when the stressor itself doesn't get removed, that's why cortisol gets a bad rap. Because if the sensory information that is representative of the stressor is continually pouring in, we are continually activating our stress response and continually pouring out cortisol into our body. And that's when and why cortisol ends up getting a bad rap, because it's one of the major endocrine factors that drives a lot of the negative health consequences, both in the central nervous system and the peripheral physiology.
Hey, Dr. Michael.
Yes.
Question. One from the chat is kind of just a statement was how stress can affect stomach health and how it's all connected. And also to that is, how does anxiety tie into this? The difference between stress and anxiety.
Yeah. So yeah, let's I don't know if let's take a minute to talk about those things. So how do we feel? It's another opportunity for the chat use. How do you feel when you're stressed? Right? Like we're calm, now we're stressed. How do we know? What signals does our body give us when we're stressed?
Overwhelmed, sweating, fast heart rate, a lot of heart rate, headaches.
Yep. Yeah, so we always have these clues, right? So that we say words like overwhelmed, but what I really want us to focus on, and I think what a good strategy is in terms of moving forward, identifying when we are stressed, is being able to pay attention to how rapid is our respiration rate? How deeply are we breathing? What is our heart rate? Are our palms sweaty, right? Are we shaky? Do we get that, right? Like the butterflies in our stomach? So that all has to do with what's sympathetic activation, right? This HPA, or stress response activation, that activates a part of the nervous system called the sympathetic nervous system that mobilizes resources for the fight or flight response, right? And Jackie, if you can let me know, crew here, we're going to do a quick show of hands. How many people have heard of the fight or flight response?
We're up to, keeps raising, 11, 12. People raise 13, raising their hand a lot.
Okay.
We're going up.
All right. Yeah. So we talk about this colloquially, right? The fight or flight response. The fight or flight response really is the stress response, right? That mobilizes resources to get us ready to fight, run away. And again, I mentioned earlier, the two things that we're naturally fearful of or have a startle response to: loud noises, rapid movements, right? Where in that situation, we actually freeze, right? So that's generally what we do in inescapable stress, right? We might attend to a thing. We're going to do a really quick calculation about like, can we take on this giant, or is it better to run away? Or if we think that maybe it would be dangerous to do either of those, we just try to freeze and like blend into the background, right? All right, so, but that is all the stress response. And in that moment, that is when we get the peripheral information. We get increased heart rates, we get vasodilation, we get sweaty palms, we get blood moving away from our digestive tract and into our major muscle groups. So all of those things. So that is one of the ways, and it doesn't have to be, right? In 2021, a year and a half into a pandemic and renewed fight against racism and a political system that like even the mention of somebody else's political party can like send us like, I don't know, bombing each other or something ridiculous, right? Like there are lots of prolonged chronic stressors that we all feel, right? And it's the sensory input that we associate with them, whether it's a visual image, a sound, a particular part of the community, a particular relative that we've had really negative experiences with, the sensory input that represents that thing becomes a stressor for us. How does this relate to anxiety? So there can be a singular event that is a stressful event, and that event passes and we move on, right? Stressors and fears are generally tied to very specific things in the environment. Anxiety is a very generalized fear or stress response, where it's just like this worry, right, about a fill in the blank, the potential of this thing to happen, the unknown about whether or not a thing would happen, right? That's when we start to, right, the very, very protective response of a stress response becomes not so good for long-term health and well-being, because with anxiety then, even in the absence of the sensory stimulus, we still have activation of the cascading events that lead to an endocrine system and a neurobiological system that's just a little bit out of kind of healthy homeostatic function. Does that?
Yeah, and another comment, too, feelings of being blown off or nobody caring about what you're going through. I think especially that's a huge one, as people have been isolated and they've kind of lost that one human touch, and then it's hard to kind of relate or talk about what you're going through with others as well.
Yeah, absolutely. And let's be honest, again, like United States culture has never been a place where it's like okay to talk about your feelings, right? And that's only been exacerbated by the distancing policies that have been in place during the pandemic, right? Where now, again, if you think about, just because we're grown-ups now doesn't mean we need social interaction any less than that infant or that toddler or that child, right? We are capable of obtaining our own resources. We are capable of obtaining our own food, stabilizing our own shelter, right? And our cultural narrative, what's the cultural narrative? We are dependent children and we grow up to be independent, right? And in that independent, all of the implicit that's associated with being independent is also like, pick yourself up by your bootstraps. I don't need anybody. I can do this on my own. And again, that implicit cultural piece is really, really damaging to what the brain actually needs for wellness, right? Because again, no matter how old we get, one of the foundational expectations of the brain and nervous system are strong social relationships and a strong sense of social connectedness. And I think no matter who we were in the before times, every single one of us has probably had experiences of loneliness, of isolation, of anxiety, of worry, of feeling disconnected in ways that we had not before, right? And that is the evidence that we should be aware of within our own selves and within our own experiences, that disconnection from each other in a community is not good, right? Neurobiologically speaking, right? We can actually feel what that deprivation feels like, no matter where we might have existed in a social structure prior to the pandemic. So There you go. Prolonged chronic stress. We got all kinds of prolonged chronic stressors, which means that for most of us, if we don't have good coping strategies, right, it's really, really easy to look at this list and all of the things that you guys would bring to the table from your own personal experiences and being like, oh my goodness, no wonder I feel like crap some days, right? Totally normal. Because culture is a giant moderator, right? Our background, our individual experience, because again, 100 trillion synapses, 100 trillion different connections, right? What are all the different ways that those synapses can be connected that provides our very unique perception from our very unique brain because of the accumulation of the lifetime of experiences. All right. So what do we do, right? Like we can never end on a gloom and doom note, but it's important to remind us of some key points that the brain is a situated organ. It's not just because it's 86 billion neurons and 86 billion glial cells. It's because they're organized in a very particular way, and behavior is an emergent property of brain structure and function. Okay. Oxytocin and dopamine are so critically important, right? Normative release of oxytocin and dopamine. No matter what social media would have you believe, there is no oxytocin release from engaging with a virtual platform by itself. The only reason that social media might feel a little bit good at times in terms of actually being fulfilling and building community is when there isn't a relationship there. But most of the time, the social media programming works on a dopamine hack kind of system. What can we do to give you a little bit of dopamine dump to keep you engaged and to keep you coming back to this platform? But that doesn't provide brain health. No matter how old we get, we are still, at our most basic, a social species. And the only way we can get that multimodal sensory experience that is necessary for brain health is when we engage in social settings. And I'm not saying, right, I totally understand that there is a great spectra of like introvert to extrovert to direct versus, you know, like I get all that, right? 86 billion glial cells, 86 billion neurons, 100 trillion connections. There's amazing neural diversity that allows us the different unique ways in which we engage. But in a neurotypical brain, social relationship is foundational to brain health. And our social interactions feed back, right? So what we've learned in the past informs how we approach a social situation. And in those social situations, that sensory input then triggers a cascade, right? A series, or I guess more, it's like a circuit, right? A circuit of events in the brain that actually changes our brain on the molecular level, right? It changes the structure of a neuron. We grow a new branch. We sprout a new leaf. We maybe retracted a branch, right? But it's these changes in the molecular level that are the evidence, as far as we can tell, are the evidence of learning, so that we can take that learning to inform the way that we approach the next social interaction. At our most basic, most foundational, the brain is a situated organ, and it's situated within a social environment. At least that is the expectation, the neurobiological expectation of the brain, is that it would be situated in a social environment. The brain is a situated organ, and humans have existed for a really long time, right? Generations of people have come before us. And so there's lots of implicit stuff that we inherit from the past that also contributes to our perceptions of the world, the way that we engage in the world, the culture that we participate in, right? We as individuals are born into a system that existed long before we did. And so we are shaped by the socialization. The brain is a situated organ, expectant of social experience. So we are shaped by socialization. And because when we're little, our survival depends upon care from others, we are socialized by paths of least resistance that are directed by caretaker, family, community, right? If you did concentric circles out, right, in terms of influence, who is most responsible for care? Who is next most responsible for care? right? Those are the paths of least, those are the norms that I need to follow to be successful in this environment, right? And then as we grow, we're all the grownups now. This is Young Professional, right? Young Professional Summit. As the grownups, we are the ones now that take charge of the social systems and continue to make these social systems happen. So we actually have a tremendous amount of choice in the direction of social systems, but we have to recognize the influence of our own experience in the way that we manage and engage. And so I want to ask people to just do a brief activity. We'll take a couple of minutes, maybe 2 minutes to write. Free response. And if you're doing this earnestly, these questions you could write about probably for, I don't know, an hour or two. All right. So where did you grow up, right? Zip code, city, whatever. How might the geography alone have considered and informed the opportunities it afforded to you, right? If you grew up in a rural area, the opportunity to go to the rec center after school was probably small, right? What did the geography implicit teach you or tell you about value or differing human value based on race, religion, socioeconomic status, right? And remembering that every single bit of neural architecture is unique, understanding that every single person that you come across also has their own unique neural architecture that informs their perspective. Okay. 2 minutes. Right. All right. So again, I'm sure there's a lot more that you could write about. Certainly, please take the chance, the opportunity to continue to think about these things, right? Because there's a lot of other implicit factors that go beyond just geography. Geography is just a really innocuous thing, right? Like I grew up just outside of Detroit. I had paved roads. There was no public transportation, working class opportunities, right? That's the kind of the neighborhood that I lived in, the schools that I went to, right? And just that, right? What is public transportation? I need a car, right? Even things like that. So lots of other implicit factors beyond just geography inform how we perceive the world. And also in terms of neural structure, what our neural structures kind of take for granted in what others have experienced as opportunities or barriers, what others have experienced as acts of affiliation versus perhaps acts of isolation. Okay. So when we're considering our own mental health and well-being, so first let me be really, really clear. Physical and mental health are not separate things, right? The way that our brain perceives the environment directly informs our stress response, how our immune system reacts, So let's really start to, within our own selves and our own social networks, let's really start to be really intentional about breaking down that physical and mental health, right? Like, it's health. We know so much. It's just health, right? But all of our background, right? How well in the United States of America, is it okay to talk about mental health at a business meeting, right? Even if it's your friend, right? How willing are we to discuss these things? Because what are the implicit or explicit consequences of doing so? Okay. So all of these things, just to really drive home that culture and individual experience are giant moderators of what we perceive as stressors from our environment. And in engaging in these kinds of conversations and in really trying to care for ourselves and our community the way that the nervous system expects us to, we really have to be a lot more aware of how our own experiences inform our perceptions and how others' experiences are just different than ours, right? We don't know anything about anybody else's experience until we learn it from them, right? We make a lot of assumptions based on how much they're like us, but we really don't know until we have a relationship and start to learn. Culture is a giant moderator of how we perceive the environment and how we perceive stressors within our environment. So,
hey, Dr. Michael.
Yeah, what's up?
One question we got is, in relating to culture, is what would be your advice to take steps towards adjusting our workplace culture to care more for a healthy brain balance?
Great question. That might be, I don't know, email me, we'll go for a coffee. Right? Like I think my bias, right, is neuroscience, and we'll get to that slide again in just a minute. But it really is, I think, what are the goals, right? What are the organizational goals? What are the individual goals, and how do you help your people achieve those the most? Because if it's I have been in some unhealthy working environments. One of the jobs that I had between undergrad and going back to grad school, my immediate supervisor actually liked making me cry, right? Like, it was a good day for my supervisor if I had to excuse myself because they made me cry. Not a healthy place, right? If you are a person in a position of authority and change, you have much more responsibility for starting those conversations, because again, most organizations have some hierarchical order to them. And the more junior one is, the more recently they've joined the team, the less power and influence they have in that organizational structure. Anyway, please, whoever asked that question, I would be happy to actually sit down. I think that requires a much more thoughtful response than what I'm able to give on this call. But no, understanding what the brain actually needs is also a really great place to start. Yeah. And this might be a good place to start too, right? That who are your people, right? If you're not in a position of control and agency in terms of policy, right? Who are your people? Who are your allies? Where do you feel comfortable? What about those people allow you to feel comfortable? And where do you feel uncertain? What about those relationships or that setting or that environment are stimulating that feeling of uncertainty? Does it have to do with the immediate situation, or is it like an associated relationship based on previous learning? And if you can't find people at work, who are your people at work? Or who are your people? Where do you find them? The question that was just asked is, how do we balance our drive to achieve and our drive to meet organizational goals while simultaneously taking care of our well-being? Because if we burn ourselves out along the way, right, we have all these workforce shortages because so many people have burnt themselves out, right? There's just too much prolonged chronic stressors coming in all the time that it just becomes really difficult to manage, right? And in American culture, it's this 24/7, right? Like, if you're not working, you're being lazy, right? Like, if you're not working, you're not making money. And so we all, especially those of us that are really motivated by either recognition or the incentive or the whatever it is, we can really land ourselves in some really, really unhealthy patterns that ultimately work against the longer term goal because we do so much damage to our physiology along the way. So back to this guy, right? That neuroscience can help. It's understanding, right? Why is it important to protect your mornings, right? Because if you start, I have a terrible habit. Call me the hypocrite. I have a terrible habit. I get up in the morning and I like to be the first one up in the morning. The house is quiet. I have 2 kids. They're 8 and 11, and I love them to death. My husband, a dog, and 2 cats. I get up in the morning. I let the dog out. I make myself a coffee. And I just love the time because it's quiet. It's like the 20, 30 minutes of time where I have no responsibilities to anybody once the animals are fed and the dog is let outside, right? But what do? I check my stupid phone so many times. Like, what? Why would I do that? So protecting your mornings is a really great way of just kind of establishing your space in the day, making sure that you're aware of where your body is at, just taking a check on your physiology. Outside. Okay, so all of these are little life hacks. I don't have to read them out loud, but every single one of them has its basis in a homeostatically balanced physiology and nervous system. It's just a matter of understanding, right? Like understanding the rationale for them and knowing yourself well enough to know which ones are going to work best for you. Because ultimately, we get our strength from other people. We have all been through really, really, really hard things. And so if we're worried about stress, if we're worried about well-being, establishing trusting relationships and building an actual sense of community, right? Because we use these words a lot. Again, culturally, I think we live at a great distance. We talk about community, but we don't really trust each other, right? So establishing who your people are and really, right, like, and they're your people. And having people is the most powerful opportunity for stress management that we have, neurobiologically speaking, right? Because resilience is not about getting through it all and we've overcome it all and we've done it all on our own. But resilience really is about the sum of our experiences, our ability to overcome and come through, not avoid and ignore and run away from, but our ability to be stronger because of the difficulties emerges from our situated brain in our situated social circumstances. And so in terms of, balance and the brain, the best thing I think we can all do is find our people and trust our people and really start honest conversation, not to tattoo everything on our arm or anything like that, but to be honest about where we're really at and what we're really up against. Because if we're not honest about those things, then we can never really come together to start problem solving so that things get better for ourselves and for our community. And so with that last couple of minutes, I will take any other questions that we have. And thanks so much for the opportunity to be with you guys today.
Well, thank you. We really appreciate it. Any questions from anybody? Well, again, thank you so much for coming today and speaking on that. It was very insightful. And I actually wrote down the social relationship is essential for brain health. Huge after, the past year and a half and distancing and isolating and all of that thing, but how important this is. So thank you. Thank you very much for all your insight today. So now for our drawing of the 2 $25 gift cards from Brew Burger, courtesy of First Response. The winners are Danielle Sauter and Nick I butchered it. Catazari. Sorry, I totally butchered it. So apologize for that. Yay, Nick. Glad he knew who he was. So we will, they are e-gift cards, so we will email those to you. And again, thank you everyone for joining us and to Notre Dame for their support. Join us tomorrow at noon for It's Who I Am, a session on personal branding, which I, as an elder YP, this is very, very new, the personal branding, all of that. So we've got a few, a male and a female that will be sharing their insights on that. Very exciting. Check out ypnsouthbend.com for all upcoming events. Again, we have a session tomorrow, Thursday, and please join us for our after hours at Adventureplex. Axe throwing, drink, bowling, games, all of that. So please join us. Other than that, we appreciate you having us today, and enjoy the rest of your afternoon. Thank you all very much.